Harnessing AI to drive sustainability is critical to achieving net zero. The risks of failing to achieve climate goals are becoming increasingly apparent, from the rise of global temperatures to escalating air pollution and the loss of ecosystems.
Climate change is a global problem, and so we need global solutions. We believe on the sustainability mission that we can't wait for net zero, and so really what we're around is reducing emissions in transport and infrastructure through the implementation of data science, machine learning and AI.
So in terms of decarbonisation of industry, we are looking at how can we decarbonize the critical infrastructure industry, the manufacturing industry, but also the maritime industry.
So the first way is kind of direct, so things like fuel efficiency, predicting weather to kind of help with route optimization. So those are very direct ways that we can use AI to help shipping reduce emissions immediately. But there's also a lot of indirect ways that we can use as well. So things like using AI to support marine autonomy, but also monitor faraway assets like underwater sea cables, but also offshore renewable structures.
But then on the other side, we are also working on policy to understand better, if you are deploying AI at scale, what is the cost from a carbon intensity perspective that involves.
At the Turing, we're working to address sustainability challenges across sectors, working with Lloyd's Register Foundation to pioneer data-centric engineering approaches which unite AI, data science and engineering expertise to improve safety and sustainability in industry.
We're already seeing big emissions reductions in transport and infrastructure. So examples just from the Turing Institute are we've seen theoretical reductions of 18% in shipping emissions, 42% reductions from HVAC systems in pharmaceutical buildings, and we've been able to generate underground urban farms that work entirely off renewable energies, which means that we're already seeing the benefits of how AI can actually reduce that CO2 count in day-to-day practice.
Collaboration is essential. That's why we're teaming up with industry leaders across the sector to take on this global challenge.
Obviously, we need an understanding of the AI problem itself, but we also need to work with companies so that we can pull through the AI research into real-world application. We need to work with government and regulators to make sure that the tools that we implement are safe. And we need excellent funders like Lloyd's Register Foundation to allow us to take that research that we initially generated and pull through into adoption in the real world.
I think collaboration between kind of industry, from the small SMEs to kind of the big companies, to class societies, to government, to work on policy as well as the technology, and make sure that they all are at least somewhat aligned. It makes our job a lot easier to kind of make sure there's real impact at the end.
Using large-scale AI systems comes with a resource and environmental cost. At the Turing, we're ensuring that the use of AI is net positive.
In the short term, we're already seeing AI that can reduce energy in transport and infrastructure systems. In the longer term, we're starting to see improvements in efficiency of those AI tools. We are starting to see new technologies like quantum, which will continue to reduce that energy usage. And over that time period, we're already seeing the benefits across such a range of different products. But the benefits that we'll see will be much larger than those training costs, certainly over a long period of time.